Alright, so very good morning to all of you. This is your educator Srishti, and I take live classes on Unacademy Plus platform. So, in this particular class, we'll be dealing with questions on atomic structure and quantum chemistry. So, basically, we'll put more focus on quantum chemistry question. Okay, so those of you who are live in this session, please do let me know in the comment section if technical things are working fine, right? If audio and the slide is working fine, so please do let me know in the comment section so that we can start off with today's session. Okay, very good morning to all of you, those who have joined this session. Just let me know in the comment section if voice and audio is clear. Okay, very good morning, Ankit. Good morning, Shanta. Now the things are working fine, so I think we should begin with the video. Right, good. Okay, so very good morning, Nidhi. Good morning to all of you. Let's take first question. So basically we have discussed a lot of questions from atomic structure in our plus courses as well as in special classes, right? But we have to discuss quantum chemistry questions now. So this particular YouTube class will be more focused on quantum chemistry questions. Okay, I'll try to take most of the concepts in this 8 to 10 questions. Okay, so let's begin with our class. Okay, so all of you just get ready with your notebook and calculators. So let's begin with today's session. Okay, so this is the first question, and this first question is on commutator. Okay, you have to tell the given commutator is equals to, and these are four options given for this particular combination. Okay, it will take some time, but please try to solve it as soon as possible so that you can develop that state of mind for examination. Okay, this is the first question. Good morning, Pooja. Good morning to all of you. Those who are present, good morning, Dhani. Very good morning, Umesh. Good morning to all of you, those who are joining this session. So this is the first question for today's session. Okay, just do not give right answers in the comment section. First, let others to solve this question, and after that, after 1 minute or 1.5 minutes, we will discuss this question. Okay, so just solve this question, and you can give your answers in the comment section. Very good morning, Shuo. So this question is on commutator. Okay, basically you have to apply the properties of commutator for this question. Good morning, Mosmi. So, okay, so 1 more minute for this question. Just quickly solve this question and let me know your answers. Good morning, Susmita. Okay, so most of you are going with option D. Very good morning, Susmita. Good morning, Sambhav. Good morning, Lovely. All right. So 30 more seconds. So you can solve this question, and after that we'll discuss this question, right? So you just have to apply the property of commutators in this particular question. Okay. Let's start discussing this particular question. So basically this is the commutator. What we have to see, right? See, what we can say that this commutator is nothing but first, right? First operator. And this commutator, this particular operator is second operator. Okay. So what I can do, I can just convert this particular part to x and y format. Okay. So how I can open up this commutator? X y commutator is nothing but xy minus yx, right? This is how we can open up this commutator, right? So now let's open these all commutators. So this is nothing but xy in minus yx. Okay, so ABC will be equals to ABC, okay, xy, then minus yx. Okay, so c xy. Okay, this way we can write this particular thing. Okay, what next we have to see over here? Plus, okay, xy bc, right, into a. So this is the first part, minus, right, a into bc. So what we are doing, we're just expanding this commutator as xy minus yx. Okay, so bc, then plus what we have to write down over here, ca, right, commutator b minus bca. Okay, so this is the part we have to do in this particular question, right? So let's expand this particular commutator. Now what is a commutator b? A commutator b is ab minus ba, right? So what I'll write down, ab minus ba into c. Okay, minus c ab minus ba. Again we can write down bc minus cb into a minus a bc minus cb. Okay, again we can write down ca minus ac into b, right, minus b ca minus ac. Now let's multiply all this part and see what actual value we are getting over here. So this is nothing but abc minus bac. Okay, this is also nothing but minus cab minus of minus, that is plus cba, right? Then we can write down bca minus cba, then we can write down minus abc plus acb. Okay, plus cab minus acb, and we can write down minus bca plus bac. Okay, so this is the total expression that we are getting over here. So ABC and ABC will be cancelled out, BAC and BAC will be cancelled out, minus CAB, then you have plus CAB, plus CBA, then you have minus CBA, right? You must be having that, yes, okay. BCA plus you have BCA, right? Then you have ABC minus ACB, right? So all things have positive and minus part. So all these, each and every quantity will be cancelled out. Okay. Now you are left with only one thing, that is 0. Okay. So basically the value of this commutator is 0. Just tell me in the comment section if this explanation is clear, right? As all of you are giving me the correct answer, so I think you are clear with this particular question, right? So let's take next question now. And this is the next question. The question is, consider the operators d square by dx square and d by dx if phi x, that is your function, is a e to the power iota kx plus b e to the power iota kx, an eigenfunction for the operators. So you have to consider this two operators and this as function. Okay, now you just have to check whether these two operators, right, will give you this function as eigenfunction or not. Okay, if this function is an eigenfunction, then you have to calculate the eigenvalues where a, b, k are real numbers. Okay, so this is the question. So basically you have to give answers in yes or no followed by your eigenvalues. Okay, so you have to tell eigenvalue for this operator, that is your dx square minus y square, dx square by dx, right, d square by dx square, and then second eigenvalue for this operator, that is d by dx. Okay, first part is you have to tell whether this function is eigenfunction or not. Second part you have to tell eigenvalue for d square by dx square. Third part you have to tell eigenvalue for d by dx. So these are three parts for this question. Okay, so right, so we got our first answer. So I'm waiting for some more time for others to just solve this question. So I think 30 more seconds or 40 more seconds will be enough for this question. Okay, so you have 30-40 more seconds for this question. Okay, right. So most of you are getting the correct answers. Let's solve this question. Okay. So let's start with this first function. So phi x is equals to a e to the power iota kx plus b e to the power iota kx. Okay, so this is your function. Now we have to operate this particular operator and this operator on this function. Okay, and we have to check the conditions for eigenfunction. Okay, so let's operate this particular function first. Okay, so d by dx on phi x. Okay, so phi x is nothing but this particular function. So what we can write down, d by dx of this function, that is your a iota e to the power kx plus b iota e to the power kx. Okay, so this is your function. Now what we have to do, differentiation of this particular part will give you this function back e to the power iota kx, and this constant, right, which is your iota k. So you must be getting iota k with this particular function and a, right? Plus iota k b e to the power iota kx. Okay, so this is the function that you are getting after first differentiation. Now iota k is basically common for both these linear functions, so I'll be taking this part common, right? So this is iota k, and this is your a e to the power iota kx plus b e to the power iota kx. So what you are observing now, that we are getting this function back. Okay, this is the function, right? This is the function, so we are getting the function back with this particular operator, that is d by dx. So what we can say, that this function is eigenfunction for d by dx operator, right? So with d by dx, this function is eigenfunction, okay, because we are getting the function back. Okay, let's now operate this particular function with d square by dx square. So what is d square by dx square? That means double differentiation, d by dx into phi x. Okay, so d by dx phi x, this result is this particular result. Okay, so I'll be using this result only. So what we can do, d by dx, right, iota k, then we have e to the power iota kx plus b e to the power iota kx, right? We just saw that this differentiation will give us iota k as the constant value with this function back. Okay, so I'll be just right using this application over here. That means this again differentiation of this function will give me iota k value. So basically I'll be having iota k and iota k with this function. Okay, e to the power iota kx plus b e to the power iota kx. That means this and this function is our eigen value, I square k, right? I square k square, and I square value is -1, so that means minus k square. Okay, so correct answer is yes, these two operators will make this function eigenfunction. That means this function is an eigenfunction for d by dx as well as d square by dx square, right? Eigenvalue for d square by dx square is minus k square, and eigenvalue for d by dx is iota k. Is it clear to all of you? Lovely, Sandra, Mosmi, Dhani, Ankit. Is this point clear? Sambhav, Umesh, those of you who are present in this session, Nidhi, just do let me know in the comment section, Shubho, if this question is clear to all of you, right? This is how we can solve this particular question, right? So let's take next question if all of you are clear with this one. It's a good question, right? So you just have to apply the basics of eigenvalue and eigenfunction, okay? Yeah. So let's take next question, and this is the next question. So let me just read this question. You have to find out the value of this commutator where x is your position operator and h is your Hamiltonian operator. Okay, these two things are given in the question, and these are four options. You have to find the value of this commutator. It can be, okay, eigenvalue can be imaginary. Basically it's nothing but a constant value, right? So you have to just go for constant value. Minus k square. See, this part we got, right, iota k into iota k. Okay, this is the eigenvalue for first differentiation. This is the eigenvalue for second differentiation. So eigenvalue first differentiation into eigenvalue of second differentiation is equals to iota square k square. Okay, what is iota square? Iota square is -1. Okay, so this is nothing but minus k square. Is it clear, Nidhi, now how we got minus k square? So 15 of you are watching this session live, and I got only 3 to 4 responses. Okay, just give me your answers. See, it's very important for you to learn the right, to just practice the concepts. Okay, so just quickly tell me your answers for this question. All right, so let's solve this question. So basically, this is the commutator. Okay, what we have to see first of all, right? We'll try. Right, okay, I'll tell you in the end that which topics are important for this chapter. Okay, I'll tell you after this particular practice series. Okay, see, this is your first operator. Okay, this is your second operator, right? So first operator and second operator. First, I'll try to just find out the value of the second operator. Okay, so this second operator is X operator into Hamiltonian operator. Okay, X operator into Hamiltonian operator. Okay, now what is Hamiltonian operator? Hamiltonian operator is summation of kinetic energy plus potential energy. Okay, Hamiltonian operator is summation of kinetic energy plus potential energy, right? So what's kinetic energy? We can write this way, that kinetic energy X plus kinetic energy Y in Y direction plus kinetic energy in Z direction plus potential energy, right, in X direction, potential energy in Y direction plus potential energy in Z direction. So basically, this is your Hamiltonian operator. Now what we have to see over here, that in this case we just have to operate this Hamiltonian operator with X position, not with Y and Z position. So I can ignore this two part and this two part. Okay, I think this makes sense to all of you, that why we are ignoring kinetic energy in Y direction, kinetic energy in Z direction, potential energy in Y direction and potential energy in Z direction. Okay, so basically we can ignore these four quantities. Why? Because we only have to deal with X position, and if we are going to include this quantity also, then this will be cancelled out or they will give us zero value. So there is no need to complicate our relation. So let's go with kinetic energy X and potential energy X. Okay, so in this case Hamiltonian is kinetic energy in X direction plus potential energy in X direction. Basically it's nothing but what we can write down for kinetic energy. Can I write this way, that kinetic energy is equals to P square by 2m? Can I write this way, kinetic energy is equals to momentum square by 2m, right? So this is nothing but px square by 2m, right? And this is your potential energy. So this is the value of Hamiltonian operator. So those of you who are clear with quantum mechanics from very basics, so you can just directly skip these all calculations and you can just go to this particular part, that is Hamiltonian is equals to px square by 2m plus vx square. There is no need to do these calculations if you are clear with the derivation part. Okay, so now what we are going to do, that we are going to substitute this Hamiltonian into this operator, okay, into this commutator. So you have x over here, then you have px square plus 2m plus vx, right? So this is the value of this commutator. Okay, so what we can write down over here, x square, right, x operator, then you have px square, right, and 2m this operator. Okay, first value, then x operator into your vx operator. Okay, this is your second value. So what is the value of this operator? Can I write down that these two are multiplicative operator? Their function is basically multiplication. So if I take two multiplicative operators in the same direction, always they will give you zero value. That means they are commutative in nature. We can find the value of position as well as potential energy in the same direction. Okay, so this value is equals to 0. Right, so now we are left with x operator, px square and 2m. Okay, so this 2m is a constant, so I'll be taking it outside this bracket. Then you have x operator and px square operator. Okay, so all I got is x operator and px square operator. So this is equals to 1 by 2m, right, x operator and px square operator. Okay, so this part we got over here. right? Not on plus, but on special classes I have completed this topic from basics. Okay, you can just complete the special classes. There are about, I think, 15 to 16 lectures, right, in special platform. You can just go to my profile. You can just find this number of classes from atomic structure and quantum mechanics. Okay, you can complete from there. So this is x operator and px square operator. Now what is this value? This is 2m. In this case, we have px at this end. That means the value is going to be negative. It is minus iota h. So the value is 2 iota h cut px. Is it clear to all of you that how we got this particular value? I have told you tips and tricks also, that how we can solve this part within seconds. Okay, so this is nothing but x, then you have px square n. So what we can write down? This is 2n, right? Basically what we can write down? We can write down n iota h cut px, right? This is the value of this particular operator, right? So now we got 1 by 2m, 2 iota h cut px. So 2 and 2 will be cancelled out. So you'll be left with iota h cut by m, because this is constant value px. Is it clear to all of you that this is the value of this operator, that is x and hm operator? Okay, this is the value of x operator and hm operator, that is your Hamiltonian operator. Is it clear to all of you? Any doubts to anyone? This part is clear, that how we got this value, right? Is it clear to all of you? I hope this part is clear to all of you, right? How we got this value. Now what we have to do, we have to just do this particular part. So which is left now, x operator into this operator, which is now iota h cut by m px. Okay, so all we need to find is this value. Okay, now this is the finalized equation, x operator iota h cut m px operator. Okay, so this is the constant part, so I can take this part out of this bracket. Okay, I can take this part out of this bracket. So this is iota h by m, then you have x and px. Okay, so this is minus iota h cut by m, because whenever we are taking any imaginary part out of the commutator, so we have to change the sign, right? I have told you this part. If it's a constant thing, then you can just take this right after out of this bracket, but if it's an imaginary part, so you have to change the sign. So this iota will be minus iota, and now you are left with this part only, right? Now you are left with this part only. So what you have to understand over here, that how we can just solve this part. Okay, let's see how we can just solve this part. So this is iota h cut by m. This value will be, right? Just tell me what is this particular value, all of you. Just tell me what is this particular value. So this particular value will be iota h cut. Okay, this value will be iota h cut. Okay, iota h cut is your value. So iota h cut and iota h cut will give you I square, iota square, then you have h cut square by m, right? So the value is minus iota h cut square by 2m. Okay, this is the final answer for this particular question. Is it clear to all of you? Any doubts to anyone? Right? Any doubts to anyone? Is it clear that how we got correct answer over here? Right? This is the correct answer, and all of you are clear with this part? Just again see the calculations and let me know if you are clear. Is it clear? Okay. What about others? Is this part clear to all of you, that how we got B as correct answer, minus h cut square by m? Okay. Right. All right. So, okay. What you can do, Susmita, just go 5 minutes back and just again see this right explanation. If still you are not clear, you can let me know in the comment section. I'll repeat it for you, right? So let's discuss all questions. If you can just again watch that part. If you are not clear, you can just definitely tell me in the comment section. Okay? Right. So let's take next question now, and this is your next question. Okay, so guys, please tell me in the comment section if my voice is clear because I'm facing some internet issues from here. Just let me know if you can hear me properly, right? So that we can continue with the session. Is it clear? Is it clear? Okay. So what questions you were asking? Just let me take a look. Okay. Right. So, why potential energy is zero? Okay. Nidhi, why potential energy is zero? Because X is basically your multiplicative operator, and Vx is also your multiplicative operator. Okay. So this and this potential energy is multiplicative operator. It is position dependent. If your potential energy is position dependent, so basically this value will be zero, right? This value will be zero because you can find the value of this this axis, that is your position, as well as potential energy simultaneously. So whenever you can find two values simultaneously, the value of commutator is zero. Okay, so is it clear? Ankit is saying already negative sign in outside, so positive hoga. One second, let's go to the explanation. Okay, so in this case, right, okay, just do not complicate this part. The simple point which what you have to think is this is iota h cut. Okay, this is iota h cut. So I'll be taking iota h cut outside. There is no need to change the sign. Okay, do not complicate the things. There is no need to change the sign. You can just take the constant as it is outside this particular bracket. So it will be plus iota h cut by m h operator into px. Okay, now this is also iota h cut, so iota h cut will give you iota square h cut square by m. So minus of this value, iota square is minus 1, so this is h cut square by m. Is it now clear, Ankit? Any doubts now? Okay, you don't have to take negative sign, right? So just do not take this thing, right? Just do not complicate the thing. Whenever you see a constant, you just take it is as it is, right? You just take as it is. Okay, there is no need to change the sign. I repeat, if you want to take this particular constant, so just take along with the same sign. There is no need to change the sign. Okay, this is iota h cut, so you take iota h cut only, right? Okay, so let's take next question now, and this is your next question. As a, if I just want to recommend you a book, so actually quantum chemistry questions are not available in so many books. Okay, so you have to search a lot of books for practicing quantum chemistry numericals. But I would recommend you just go for any coaching material. Okay, and solve the questions given in that particular material, right? Because it's not possible for you to just search 7 or 8 books for the questions, right? So what I would recommend you, that solve previous year questions. Okay, from 2 3 examinations, just you can solve previous year questions from JE, you can solve previous year questions from JAM. Then for GATE, okay, some questions for GATE, not all of them, because some concepts are very typical. Okay, and you can just go for any 2 3 masters level entrance examinations, and then you can go for any notes. Okay, just search for any coaching notes, you can solve questions from there. Okay, if you want to just complete quantum chemistry, so Shweta, I have completed this particular part in special classes. Okay, in special classes, so these classes are available free of cost on Unacademy Plus platform. Okay, you don't have to pay anything for these classes. You can just go to my profile, you'll find the link in the description box. You can go over there and you can attend all classes from quantum chemistry as well as atomic structure. Okay, atomic structure, so these two topics I have completed on special platform, right? So these classes are available free of cost, so you can complete from there. We have discussed, I think, a good number of questions there also, right? So you can complete it from there. Okay, so glad that you all of you are actually solving the questions. Okay, you're giving the correct answers. So very good to see that. Let's solve this question. So what we have to do, we have to find out the normalization constant. Okay, so how are we going to find out this normalization constant? Basically, we have to integrate this function in 0 to a limits. So it's like pi star pi d tau is equals to 1, right? This is the probability function. This is how we can find out the value of normalization constant. Okay, so let's do this now. So this is 0 to a, right? 0 to a, and phi star is also this function and phi is also this function. Okay, so you have n square a minus x square dx is equals to 1. Okay, so this is the function and that's how you're going to find out the value of n. So I'll be taking n square outside. So this is n square a square 0 to a minus x square dx is equals to 1. Okay, so let's expand this a minus b function, which is a square plus b square minus 2ab, right? So n square a square, this is a square plus x square minus 2ax dx is equals to 1, right? So this is how we can expand this function is equals to 1. So now this is the constant value. So I'll be writing like this, a n square a square. So a square integration of dx 0 to a, right, plus x square integration of integration of x square 0 to a minus 2a integration of 0 to a x dx, okay, is equals to 1. I hope this part is clear to all of you. So what this will give you? This will give you n square a square, right? A into integration of dx is x. So x 0 to a, right? Then you have x square, which is x cube by 3, 0 to a. Okay. Then you have minus 2a x square by 2. Then you have 0 to a, right? So let's solve this here only. So what we can do over here, so this is the constant part and it is equals to 1. Okay, so you have now n square a square outside the bracket. This is your a x minus 0, right? That is a minus 0, so this will give you a, right? Plus 1 by 3, so this is your a cube minus 0 cube. Okay, minus 2a by 2, 2 and 2 will be cancelled out, so you're left with minus a square minus 0 square. Okay, so this is how we can solve this particular function. Now what we are left with, basically we are left with, this is your a square, right? Yeah, this is a square. So now we are left with a cube, right? This is your a cube plus a cube by 3 minus a cube, right? And into n square by a square. N square by a square. So this and this will be cancelled out. Now you are left with n square a cube by 3 is equals to 1. So this is n square a5 by 3, okay, is equals to 1. So n is equals to 3 by a5 under root. Is it clear to all of you? I hope you all are clear with this question, right? Because you're giving me the correct answer, right? So very amazed to see this particular thing, right? So this is how we can solve this particular question, right? Okay. So let's take next question if all of you are clear with this one. So this is the next question. Okay, so the question is, what is the probability P for the particle of, we have to find the particle in the central third region of 1D box, okay? So you have to find out the probability if this particle is in ground state. Okay, so central third means basically you have to find out the particle in middle third or third center, okay? Middle third. Is it clear now? So, right, Ankit, middle third, right? Basically, you have to find the particle in middle third region or central third. Is it now clear that what exactly we have to find? So I'll give you some hint. See, let's suppose this is one dimensional box. Okay, this is your one dimensional box from 0 to L. Okay, so what we have to find out, if I just divide this box in three halves, right? So this will be 0 to L by 3, this will be L by 3 to L by 3, and this will be L. Okay, so what you have to find out, you have to find out the probability of particle in this box, okay, in this area. You have to find out the probability of finding the particle in this particular area, that is L by 3 to 2L by 3. I think now the question will be very simple, okay? This is the units or this is the limits for this particular question. In percentage, you have to give your answers. Okay, Shivu? Just give your answers in percentages. Okay? Okay. So we got three different answers: 60.91%, 8.64%, 50%, 93%. Okay, right. So guys, pay attention. and let's see how we can solve this question. Okay, so basically what's the question? The question is, if you have 1D box, that is one dimensional box having length 0 to L, right? You have to find out the probability of particle in middle third region or central third region. Okay, now let's suppose I have a box, right, and the limits is 0 to L. That means the length is 0 to L. Okay, so I have to find out the probability in middle third. So from this thing we got a clue that we have to divide this in three parts. Okay, we have to divide this in three parts. One is your 0 to L by 3. This is L by 3 to 2L by 3, and this is 0 to L. So basically this portion is L third portion, 1 by third portion of this box. This middle portion is also 1 by third portion, and this is also 1 by third portion. Okay, see, next is we have to find out the probability in the middle third region. Now this portion is known as left third. Okay, this is known as your middle third. Okay, middle third or central third. Okay, this is also known as central third, and this portion is known as your right third. That means it's in extreme right. Okay, so right third. So now what we have to find out, we have to find out the probability of particle in this region, that is from L by 3 to 2L by 3. Okay, this thing you have to find. Okay, so let's see how we can solve this particular question. Okay, so whenever we have to find out this probability type of questions, so that means limit is L by 3 to 2L by 3. Okay, 5 star into 5x, right? 5 star into 5x d tau. This part we have to find out. Okay, this part we have to find out. So what is your 5 star for one dimensional box? 5 star is 2 by L, right? Sine n pi x by L. 2 by L sine n pi x by L, right? So let's find this particular thing, right? So it's like 2 by L sine n pi x by L, right? So what we are going to do, this 5 star is also this particular function, and this phi is also this particular function. Okay, so what we can write down, if I just substitute the value, so I'll be getting something like this: 2 by 3 L by 3 2L by 3 sine square n pi x by L dx is equal dx. This particular part we have to find out. Okay, now if you have completed this quantum chemistry lectures from special classes, you must have remembered one particular thing, that I have told you that this particular part is very lengthy to solve. So after solving this particular part, we just got one formula which you have to remember of probability. Okay, so what is that formula? Probability is equals to x by L minus 1 by 2n pi sine 2n pi, right? 2n pi x by L. So this is the formula of this particular function with limits a to b. Okay, this is nothing but integration of this particular formula only, right? So when you integrate this particular formula with limits a to b, you will be getting something like this. Okay, so it's better to remember this particular formula, but if you are not remembering this particular formula, if you're not clear with this formula, or you're not good in remembering the values, so you can just solve it step by step. Okay, you can solve this question, but we are going to use this formula directly. Okay, that is x by L minus 1 by 2n pi sine 2n pi x by a by b. Okay, so this is the formula. All you need to do is just substitute this particular limit to L by 3 and L by 3. Okay, let's do that. Let's substitute the limits and find out the value. So x is 2L by 3, so this is 2L by 3L. Okay, minus 1 by 2n pi. Let's take n is equals to 1, or let's just write down this way, 2 pi. Okay, it's like 2n pi, and then you have L by 3. Okay, so L will be cancelled out. Now we'll be left with only 0 part. Okay, this is nothing but L by 3. Okay, this is also L, so L and L is going to cancel out, so you'll be left with 2 pi by 3. Okay, this is the part over here, so you can just substitute the limits over here, and you'll be getting some value around 0.609. Okay, you'll be getting some value around 0.609. So now once you calculate this particular value, you'll be getting 0.609, and you just have to multiply this by 100, right? And you'll be getting 60.9%. Is it clear to all of you? Any doubts to anyone? You just have to substitute the limits, and you have to find out the correct value. Okay, so the value will be 0.609 into 100, that is 60.9%. Okay, this is a lengthy question, so we have maximum chances that this won't come in jam. Maybe if they'll come, so they will just go with left half and right half, not more than that. Okay, but the explanation is very simple and the concepts are very simple. Okay, so we can always practice these type of questions for high. Okay, is it audible now? Screen is visible and voice is audible. Anyone who's watching it online? So four of you are live, right? So just let me know in the comment section if it's working fine. Okay. All right then. So this is the next question. So in this question, this is the wave function given to you. You need to find out the orbital for which this is the wave function, right? For which the wave function is given, you need to find out the orbital. Then you need to find out energy, then radial node, angular node, LZ value, L square value, and Lx square plus Ly square, and position of node. That means nodal plane distance. Okay, so these are things you have to find out for this question. No issues, you can still try this question. It's an important one. Okay, it's for hydrogen atom, so it can definitely come in your examination. Okay, just make sure you complete it as soon as possible. Okay, is it done, guys? So let's start with first part. So for which orbital this function is given? For mathematics, it's better that you should start with NCRT books. Okay, it's better that you should start with NCRT books. And in this question, a lot of mathematics is not required. This is actually simple. Okay, let's see how we can solve this question. Okay, yes. So all of you tell me for which orbital this function is given. First of all, just let's solve part A. Okay, just tell me orbital. That means you have to tell the complete definition of orbitals with n value and with L value. N and L. Okay, just tell me what is the n value for orbital and what is the L value for orbital. Okay, great. Good work, Ankit, Mosmi. So this is the constant part, right? This is the constant part, so I'll write down n for it. Okay, so let's see how we can solve this particular question. So phi is equals to n, you have 6r by a naught minus r square by a naught square e to the power minus r by 3 a naught cos theta. So this is the function given over here. Okay, now we have to find out value for n and L. For a value of L, we need radial part. Okay, so what we can do, we can divide this function into two parts. First is your radial part, which is dependent on n and L value, into your that part. Okay, angular part, which is basically dependent on theta and phi. Okay, theta and phi, or what we can write down, it is basically dependent on L, N, M value. Okay, so this is how we can write down this particular function. Okay, so for just N and L value, we need to find out radial part. Okay, so radial part, that is R N L, is basically directly proportional to this part, to ZR by N A naught to the power L. Okay, e to the power minus ZR by N A naught. So this is how this radial part is dependent on these two functions. Okay, that means what I need to do, I need to find out this free R. Okay, so the power of free R is going to be your L value, is going to give you L value, right? And for N value, we have to see this exponential part. Okay, so what we can say over here, that this part is your radial part. Okay, and this part is your angular part. So this is your angular part, that is your theta phi, and this is your radial part. Okay, right? So let's find out the value of L. Okay, so basically what we need to do, we need to find out this free R. Okay, how we can find out this free R? If I take R common from this function, so this function will be right R, then you can then you have 6 by a naught minus R by a naught square. So now this is your free R and R to the power 1. So basically you have L is equals to 1. Okay, so this way you can solve this thing, that L is equals to 1 over here. Next, what we need to do, we need to find out value of N. Okay, see, this is minus ZR by Na naught. Okay, minus ZR by Na naught. So this is for hydrogen atom, that means Z is equals to 1 and N is equals to 3. Okay, so N is equals to 3 over here. That means the orbital address is your 3p. Okay, the electron address is your 3p. Okay, so electron is basically present in 3p orbital. So I hope this part is clear to all of you, that orbital is 3p. Okay, next is we need to find out the energy value. So how we can find out the energy value? Energy is nothing but, according to Bohr's theory, minus 13.6 z square by n square. Okay, it's minus 13.6, z is 1 over here because this is for hydrogen atom, and n is 3 over here, that means 9. Okay, so minus 13.6 divided by 9 electron volt is your energy. Okay, I hope all of you are clear with this part, that minus 13.6 by n electron volt is your energy. Okay, next is your radial node. So what is radial node? Basically, radial node is n minus L minus 1. Okay, n is 3 over here, L is 1 and minus 1. 3 minus 2, 1. So radial node is 1 over here. Is it clear to all of you? Any doubts to anyone? Radial node is 1 over here, right? So radial node is equals to 1. Right, radial node is equals to 1 over here. Next, what we need to find out? We need to find out angular node. So angular node is equals to L is equals to 1. That means angular node is also 1. Okay, angular node is also 1. Next is we need to find out value for LZ. Now what is LZ? I can write this particular LZ using this MHZ. Okay, that means for LZ I need to find out the value for M. Okay, for LZ I need to find out the value of M. Okay, so let's for M value we need to pick this angular part. Okay, so angular part is cos theta. Okay, angular part over here is cos theta. Okay, so let's see how we can find out this value of M and L, right? So basically angular part, that is your y theta phi, is directly proportional to n cos to the power L minus mod M, right, into sine to the power sine theta to the power mod M, and you have e, right, e to the power iota m phi. Okay, iota m phi. So this is your angular part over here. Now there is no exponential part in this particular function, so what I can write down, that m is equals to 0. Okay, there is no angular part, so what I can write down, m is equals to 0, right? So m is equals to 0. So let's get back to LZ, which is m h cut. Okay, so this value is 0. Okay, this particular value is 0. Next, what we need to find out, we need to find out value of L square. Okay, so what is L square? Can I write down L plus 1 h cut square? Can I write this way? L square is L plus 1 h cut square. Okay, so this is the value of L square, L plus 1 h cut square. So L value is equals to 1. So what we can write down, 1 into 2 h cut square, 2 h cut square. Okay, so L square value is 2 h cut square. Then after that, what we need to find out, L x square plus right, L y square. So we know this thing, L square is equals to L x square plus L y square plus LZ square. Okay, so if I take LZ square over here, so L square minus LZ square is equals to LX square plus LY square. Okay, and LZ square, this particular function L square is 2h cut square. Okay, so this is 2h cut square and this value is 0. So that means Lx square plus Ly square is also 2h cut square. Then next, what we need to find out, we need to find out position of lobe. Okay, so let's find out position of lobe. So what we can do for position of lobe, we can just actually put this particular whole equation, radial part is equals to 0. Then only we can find out the position of load, right? A position of node. So let's put this particular part is equals to 0. So this part is this part. Okay, 6r 6 by a naught. Okay, it's I think 6 by a naught. Then we have r by a naught square. Let's see. Yes, okay, it's r square. It's r square by a naught square. Okay, and this is your e to the power minus r by 3 a naught. This is your radial part. Okay, 6r by a naught minus r square by a naught square, e to the power minus r by 3 a naught. Okay, so what I'll do, I'll take this r common, right? Just like I solved it for your L value, I'll take this r common, and this will be now 6 by a naught minus r by a naught square, right? E to the power minus r by 3 a naught. That means I need to find out the position for node. Okay, that means electron density is equals to 0, radial electron density. Okay, so I'll put this value is equals to 0. Now we can have three functions. Okay, what is the three function? What are the three functions? R is equals to 0, this is equals to 0, or what we can say, 6 by a naught minus r by a naught square is equals to 0, or what we can say, e to the power minus r 3 a naught is equals to 0. Okay, see, r is equals to 0, and if this particular part is equals to 0, that means r is equals to infinity. Okay, so can I say these two conditions are boundary conditions? Can I say that these two conditions are boundary conditions? right? These two conditions are boundary conditions because limit for radial part is 0 to infinity. Okay, so we don't have to consider these boundary conditions because always at boundary conditions you are going to have 0 electron density. So this is not a node, these are boundary conditions, right? So you don't have to consider these two things for boundary conditions. That means this value will give us position of node. Okay, so 6 by a naught is equals to r by a naught square. So this a naught and a naught will be cancelled out and you are left with r is equals to 6 a naught. So this is the value of your function, right? This is the value of your node. Is it clear to all of you? This is a lengthy question, but I hope you are clear with this concept because in class also we have solved, I think, one question on this particular concept. Okay, this is actually a very good question, right? So in this particular question, we discussed all concepts for hydrogen atom. Okay, for hydrogen atom we have three polar coordinates. We have r, then we have theta and phi. Okay, for r the limit is 0 to infinity, for theta it's 0 to pi, and for phi is 0 to 2 pi. Okay, this is the radial part, these two will give you angular part. Okay, right? I hope this one is clear. So I think we have one more questions. Let's take this question. Alright, so let's solve this question. The question is number of energy states and energy level in the range of this energy for a cubic box of side A. Okay, cubic box means we are discussing for 3D box. Okay, that is your three-dimensional box. So what we have to do, we have to find out this energy states and energy level. Okay, so basically what's energy for 3D box, that is three-dimensional box, nx square plus ny square plus nz square h square by 8 ml square. Okay, so this is the energy for this particular box. Okay, now what we need to do, we need to find out total energy states and energy level less than 15h square by 8 ml square as the value of energy. Okay, so let's form number of sites. Okay, let's see how many possible combinations we can have over here. So what we can do, first level will always be 1 1 1. Okay, so degeneracy will be 1 for first level, and energy will be E is equals to 3h square by 8 ml square. Okay, E is equals to 3h square by 8 ml square. Then after this we can have one possible combination 1 1 2. Okay, because energy over here will be 2 square 4 5 and 6 6h square by 8 ml square. Okay, so we can have these three possible combinations. Okay, for this combination 1 1 2 we can have three possible combinations. Okay, after 1 1 2 we can take 2 2 1. So basically 2 2 1 will give you 4 and 4 8 8 1 8 plus 1 9. Okay, so it will give you 9h square by 8 ml square. So next you have 2 1 1 2 2. Okay, so basically this is also 1 2 2 type of combination, so you can have three possibilities over here. Okay, after this what you can take, you can take 2 2 2. Now what is 2 2 2? This is 4 4 and 4, that means 8 plus 4 12. This will give you 12. But if I take 3 3 1 1, so this will give you 9 10 11. So that means we have to take 3 1 1. Okay, so 3 1 1, so again it will have three combinations, so it is 11 square, right? 11 h square by 8 ml square. Okay, 11h square by 8 ml square. See, this is a complex question. It's a lengthy question, but it's not difficult one. Okay, see, we have discussed this concept already, so we can solve this question. Okay, with this one lengthy question you can actually solve simpler questions. Okay, so this is 3 1 1, so we can have three possibilities again. After this thing we can have 2 2 2. Okay, so that means 12h square by 8 ml square. Any other possibility left before right, just less than 15h square by 8 ml square? Yes, there is one more possibility. If I take 1 2 3, okay, so 1 2 3 will give you 4 and 9. Okay, so 14, it's also less than 15. Okay, so we can take 1 2 3 combination. Okay, for 1 2 3 combination we have three different energy states, so what we can say, that we can have six combinations. Okay, 1 2 3 4 5 6, we can have six different combinations for 1 2 3. Okay, this will give you 14h square by 8 ml square. Okay, so that means how many energy levels we have? 1 2 3 4 5 6. So we have six energy level. Now we have to calculate states. Okay, so state is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So we have 17 states. Is it clear to all of you? Is this point clear? Right, then how we got 17 states and 6 energy levels. Okay, it's a good question. So this is how you should solve it. Right, and there is no need to just right, get afraid of this big question. Just keep solving this question, right? Just go step by step, right, with a good state of mind. You can definitely solve this question, right? I hope this is clear to all of you, right? Let's take next question now, and I think it's going to be the last one. Yes, okay, this question is last question and it's a good question, so let's see how we can solve this question. Right, this is the question, and the question is, at time t is equals to 0, the wave function for hydrogen atom is this one, the expectation value of energy. So it's based on superposition principle. last question. Okay, so now I think mostly you will get the idea that what all topics you have to study in this chapter. Okay, because I have I think covered each and every topic with these questions. Okay, so the questions we are doing, you just have to study those topics. Okay, so let me help you with this thing. All of you can solve this question. So you can in this particular topic you have to start with operators. Okay, operators and functions. Operators and functions. In this operators and functions you have to study properties of this operators, right? And then you have to study Hamiltonian operators and Hermitian properties also, right? Hermitian operators and all operators properties. Okay, commutators and operators, all things that we have discussed in operators. Okay, after operators you have to start with application of Schrodinger's equation, and in jam level there is only one application which you have to study, that is particle in a box. So PIB model, you have to study PIB model, one dimension, two dimension and three dimension. Okay, just the equation, and you have to study the energy, degeneracy and all these concepts. Okay, after PIB model you just have to study hydrogen atom. Okay, these three topics you have to study. For quantum you don't have to go in depth of this topic, you just have to study whatever content I have provided you. That will be more than enough for this particular chapter. Okay, and then you have to complete this atomic structure also. Okay, you'll be having more questions from atomic structure and less number of questions from quantum mechanics, but no one knows what's going to be the pattern for this upcoming examination. So you can at least complete quantum mechanics from my classes. Okay, that will be more than enough. See, if I go to jam level, maximum you will get one or two questions from quantum mechanics, right? But you have to study it, right? The questions will be very simple, but you have to study quantum mechanics. Okay. Basically, if I take atomic structure and quantum mechanics, you can see three questions collectively from these two chapters. Okay, so 1 more minute for this question. Then we are going to solve this question. Okay, so you have 1 more minute. Okay, so let's discuss this question. So basically, this question is on superposition principle. Okay, this question is on superposition principle, and basically it's a concept which actually you can understand, right? And in this particular concept, what we have to do, see, this is the function given, wave function. So what we can write down, phi is equals to 2 by under root 10 phi 100. Okay, then we can write down 1 by under root 10 phi 210. Then we can write down root 2 by root 10, right, phi 211, and plus root 3 by root 10 phi 211. Okay, this is your particular equation over here. So what I can write down, that phi is equals to C1 phi 1 plus C2 phi 2 plus C3 phi 3 and C4 phi 4. Okay, so this is your function. So first of all, whenever you have to find out this term, that is your expectation value. Okay, so that means you need to apply the principle of superposition, right? So whenever you have to find out expectation value, so first of all you have to check that if this function is normalized or not. If this function is normalized, then you can proceed with this calculation of expectation value. Okay, so now what we have to check, that if this function is normalized or not. And how we are going to check this function is normalized? C1 square plus C2 square plus C3 square plus C4 square should be equals to 1. Then only we can say that this function is normalized function. Okay, so C1 square, what is C1 square? That is your 4 by 10. Okay, C2 square, C2 square is your 1 by 10. Okay, 1 by 10. Then you have C3 square, it's 2 by 10. Okay, 2 by 10. Then you have C4 square, and C4 square is 3 by 10. Okay, 3 by 10. So 3 and 5, and this is your 7. I think there is some mistake. Let's see. It should be 1. Okay, so if I just want to calculate this particular thing, so this is 3 and 5 and 6 and 6 and 4. Yeah, it's correct. Okay, you have 4 by 10 plus 6 by 10 is equals to 10 by 10, which is equals to 1. Okay, that means this function is normalized. Okay, if this function is normalized, so how we can find out the expectation value of energy? We need to find out the expectation value of energy, right? So we are going to write down this way, that expectation value of energy or average value of energy is C1, right? This is basically we can write down probability 1 plus E1 plus P2 E2, right, plus P3 E3 and P4 E4. Okay, so basically P1 E1 plus P2 E2 plus P3 E3 and P4 E4. Okay, so now what we need to find out? We need to find out P1 P2 P3 P4 E1 E2 E3 E4. Okay, so what is your P1? P1 is nothing but C1 square. P2 is nothing but C2 square P3 is nothing but C3 square and P4 is C4 square. Okay, so this is 4 by 10, this is 1 by 10, this is 2 by 10, and this is 3 by 10. Okay, next is E1, E2, E3, E4. So E1 is equals to minus 13.6. It's for hydrogen atom. Is it written? Yes, it is given that it's for hydrogen atom. So Z is equals to 1. So 1 by n square. Okay, basically what is the value of n? So if I just go to this function, for this function value of n is 1. Okay, it's like phi, right? N L M. Okay, this is how we are writing down the functions phi n l m. Okay, so basically n is equals to 1 over here, n is equals to 2 over here, n is equals to 3, and n is equals to 2. Okay, so for these three functions n is equals to 2, for the first function n is equals to 1. Okay, so what we can write down? 1 square. Okay, E2 is equals to minus 13.6 divided by 2 square, minus 13.6 divided by 2 square, minus 13.6 divided by 2 square. So this is E3 and E4. Okay, this is E3 and E4. So what we can write down now? P1. Okay, P1, what is your P1? P1 is 4 by 10. Okay, P1, E1. E1 is minus 13.6. Okay, plus what we can write down? We can write down P2, that is 1 by 2. So basically let's add these three values. So this is 6 by 10. Okay, 6 by 10, and this value is minus 13.6 by 2 square. Okay, this is how we can find out the expectation value. Just quickly tell me what you are getting after this, right? This particular solution. हेलो, हाँ जी भैया, आप आ जाइए. हाँ जी, आ जाइए. 10 मिनट्स में आ जाना भैया. ठीक है, चलो आ जाओ, आप आ जाओ. Right. So I think you are getting minus 7.8. Okay. You are getting minus 7.8, right? So minus 7.8 electron volts. So this is the correct answer over here. Minus 7.48 electron per volts. Okay. This is how you should solve it. Just recheck the calculations. Okay. I have some work. So now I'll conclude this particular session. I hope this question is clear and this explanation is clear. Okay. If you have any more doubts, you can let me know in the group. Okay. So this is how we should solve questions from quantum mechanics and atomic structures. Okay, I hope you found this session useful. If you did, so you just give it a like on this particular session. I'll see you in the next class. If you have any more doubts, so you can let me know in the group. Okay, so right, all right guys, take care. Bye bye.